During this lecture, we will continue our discussion related to the inheritance and polymorphism, also try to recap what we discussed before, and cover additional topics for today. So here I would like to ask you to actively participate in our discussion and provide answers, suggestions, and yep, don't be shy, and your participation is really important. Let's try to recap what we discovered before. We have three main object-oriented programming principles: encapsulation, inheritance, and polymorphism. We'll be happy to hear from you about details. So what is encapsulation, inheritance, polymorphism? Any volunteers to share their knowledge and to explain in detail?
Encapsulation, it's when we hide main it's when we hide the main mechanism, how it works, so the person who uses it, this person doesn't really know how it works under the hood, and it cannot access, for example, some fields if we don't allow this person to do so.
Okay. Any example from the real world?
When we Perhaps when we sort something in an app, we don't really know the algorithm, how it works, but it works.
Okay. Thank you. You are right. But I can see Yaroslav also raised his hand. Yaroslav,
It's
please.
about real world example, yeah. That's about asking a name. You firstly asked your name, and then you decide you tell or not. That's encapsulation. So you hide your name, so to say, your field.
Protect from external world. Okay,
Yeah.
one of good example, but makes sense. Any other ideas, suggestions? Yeah, those answers are correct. So actually, we are hiding details. In the real world, you're not getting into details when you are interacting with something. As I said before during the previous lectures, if you are driving a car and you are switching between the gears, it's not required to know how the transmission works under the hood and inside your car. So it's one additional good example of the encapsulation. So you have an interface handle, and you are switching between gears. And yeah, all of these details of this work is working inside of this mechanism. Here, we can also discuss the details and remember the implementation of the bank account. So if you are charging your money from the bank account, you are not, it's not even interesting to you how everything works under the hood, which transaction happening, which additional checks and verification happens. You just need your money. So you are calling the method, withdraw, and get your cash back. Good. Inheritance.
So when we have a superclass and we can have a couple of subclasses which will inherit attributes from the superclass. For example, we can have a superclass vehicle and a subclass car, for example. So the attribute speed, and the speed will pass to the car. And for example, car can have additional special attributes which will only belong to the car class.
You're right. Yeah. Good example. Any other suggestions? Or examples?
Okay, maybe one more example as during the previous lesson, but we can refer to any like connected to animals. So we have one superclass, the same as in biology. For instance, it can be also connected to plants, connected to planets, to everything. So we have one of this object, but subclasses is a bit more specified, and it inherits this properties of superclass. For instance, if it's animal, it will be superclass animal, and it will have its name, what it says, how many eyes it has, and each animal may have different this means, this properties. For instance, for a dog, it will be barking. For a cat, it won't be barking. So like this specification.
Thank you. You're absolutely right, and we will be revising it one more time today with details. And yep, good example. Thanks. And the last one, polymorphism. Yeah, please don't be shy.
It is a different implementation of the same method. Like, for example, the superclass, maybe shape, has some children classes like circle and square. And the shape has a method like draw shape. I don't know. So for a circle, it will be implemented in a whole different way than for a square. So each of these children classes will have their own implementation of draw shape.
That's right. So details of the implementation depend on the type of a child and inherited classes. Yep. So calculation of the squares or circles might be a different one, but nevertheless, they have the same interface to get the shape, to get the area of this field or get the perimeter of this object. Yeah, and we have a general object and interface like get perimeter, get area, but the way how it's calculated might be different. Good example, thank you. Let's check in details. So here you have an example, and probably you already saw it from the previous lecture when we have a savings account which extends a bank account. And as you correctly mentioned, so when we are extending, when we are inheriting the object, we are adding additional characteristics and interfaces into it and using the parent identification on parent functionality. So first of all, the keywords here are extends. When you are defining your class, you should provide the definition and the name, like a savings account, and which class you are extending. So here on the top, it's pretty clear that saving account extends the bank account. So we are inheriting everything from it. Later on, we have constructors. Constructors like public saving account. So it's the way how we are identifying the object. Saving accounts could be identified by providing initial balance and interest rate. And yeah, here we have in the implementation quite interesting keyword called super. Let's try to remind what does it mean, why it's being used here. Yaroslav, please go on.
We are calling the main constructor of superclass with we are calling the constructor with the double oh my god, argument with a double argument.
That's right. Well, we are calling it, but you're also right that we are calling the base constructor. So I have even prepared it in a code, and we can quickly revise it from the IntelliJ IDEA. As you can see here, let me quickly switch to the presentation mode. Yeah, so it's a parent class called bank account. We are defining it as a balance. We have a constructor, so typical bank account should have the balance. Of course, we should get the balance. So as a user, you need to obtain the information about funds you have on your account, and you should have the possibility to withdraw the money. So you're saying, I would like to get $10 from it. Your application verifies if amount is eligible, so if it's bigger than the balance, and you are just adjusting balance after the withdrawal. And yeah, so additionally, we have a savings account. We have keyword here, extends bank account. So we are inheriting it, and we are providing additional parameters, interest rate. While we are creating it, we should provide a balance and interest rate. And it's quite important to call the super constructor because this field is required. So it's not possible to have the bank account without any kind of balance. So super, if you even click on it, will be directly transferred to the bank account constructor definition. And even more, in case when we will remove it, for example, IDEA will highlight that we have an issue. So we cannot define the objects because the parent class requires a definition of balance. That's why in many cases, it's important to call super constructor and provide all defined and satisfy all defined rules which requires from the bank account. Yeah. So here, I think it's clear. We have an interest rate as an additional field. We are identifying and reusing basic rules and basic constructors here, and extending the functionality of all of this logic by savings account by get interest method. As a result, in case when you will define the savings account, let's probably go to the main method. Oh, not this one, but savings account S equals new savings account, balance 100, interest rate 0.1. So by using and getting the access to the possibilities of savings account, we can see get balance and withdraw the money, right? So we can withdraw $100, and also we can even get the interest rate. The implementation of withdraw method is in the basic bank account class here. So we are reusing. And yeah, where we have here encapsulation. What we are actually encapsulating in these examples. Okay, I can explain. We are encapsulating the way how we are withdrawing. So how we are getting the money, how we are getting the balance. And also we are encapsulating the logic how we are identifying the interest rate. Additional example about the inheritance is that in case when we are calling in the main method savings account object, it's possible to call the basic implementation implemented in the base class and also get the get interest. I think it's clear, but if you have any questions, please raise your hand. Okay, then let's move to the next one. So with inheritance, it's clear. Let's go to the override of methods. So what is overriding? This mechanism allows a subclass to customize or completely replace the behavior of methods defined in the superclass. Again, let's go back to the implementation of the bank account. And we have bank account and savings account, which is a subclass of the bank account. And you can see here the method withdraw. Can anyone explain what is going on here? and what we are reusing and what we actually extending. Guys, offline, online, please don't be shy. But okay, I can quickly explain. We have a method withdraw. Method withdraw overriding the basic implementation of the implemented in a bank account. Previously, you remember that we are just subtracting some of amount of money from your account and checking if it's a valid transaction or not. But here, in case we are talking about a savings account, we may have additional transaction fees. And this logic should be a bit different and should be overridden comparing to the base one. As you can see here, we are checking if amount is higher than 0, if the balance is also valid one, then we are recalling the parent withdraw method with a combination of amount plus transaction fee. I think it's clear, and it was already mentioned before. And yeah, let's recheck the polymorphism. As you perfectly said, that a good example is taken from the biology, and we can reuse some of animals definitions and manimals classifications for our polymorphism. So here in this example, we have a basic class animal. Animal makes sounds, and it's a general implementation. It could be even abstract or even placed in the interface, but we will talk about it a bit later. Class dog, class cat not overrides, but extends the animal class and can override the method make sound. Of course, dog should bark, cat should meow. How it works? On the right side here, we can define all of these objects like general animal, dog, and cat like an objects of parent class of animal. And yeah, in case when we are calling them, my animal makes sound, it will provide them some sound in a console. My dog makes sound, will bark. My cat makes sound, will meow. Why it's working in this way? In case even if the definition here is a parent class, but in case you are define it as a subclass here, it will use the implementation of the subclass. That's how polymorphism works. So we have a unified interface how the make sound method being called. And the Java and other object-oriented programming languages know precise implementation of this make sound method based on the class definition here. So it provides an additional way of abstraction. So for example, in case you are providing a general logic working with animals, you can work with a parent class animal and call make sound in your library, working with a higher level abstraction. But in case of calling make sound method inside of your library, it will use the implementation provided by subclasses. That actually works in the same way from the list. So we may have different kind of lists, like array list, linked list, any kind of other lists implemented even by you. But it will have the general methods like add, remove all, and so on and so forth. And you can unify your logic and unify your library by working with the unified methods defined in the abstract classes, interfaces, or parent classes. That's how polymorphism is working. Any questions here? Good. Then let's take a precise look on these examples and a casting. I'm pretty sure some of you already using that and can explain in a brief words what does it mean. Any volunteers, any suggestions from your side, please feel free to raise your hand, unmute your mic, and join into this discussion. Okay, let me try to explain that. We have typical example. As we discussed before, animal is a base class. Dog extends the animal, and dog has additional method fetch. So animal has only one method, make sound. We are extending the implementation of dog by providing additional methods. So dog fetches the ball. Well, I'm not sure if any kind of bird can do that, or even some cockroaches, for example. So it does not make sense to implement this method in a base class. So we are extending and define it just for the dog. But imagine the situation: you are defining your main class, and you defined my animal as a new dog. Okay, we can call my animal make sound, but it's not possible to call my animal fetch. So let me provide a good example here in a code. Yeah, we have animal. It's a get name and abstract voice method. We have cat, which is saying meow. We have a dog. Let's extend the dog implementation and public void fetch. Let's say, okay, I am fetching. Let's go to the main implementation. We are defining animal a like a new dog. Let's call it tracks with h5. What we can do, we can call the voice method. But what is not possible to do is we cannot fetch. Yes, you can see in the definition of the animal class, there is no fetch method. It's in implementation of the dog class. What shall we do in this situation if we are working with a parent class and want to cast it to the subclass and call a fetch method? This functionality called fetching. So we need to precisely say that this is a dog. Okay? Dog D equals brackets dog and A. And yeah, if you're calling it, you can easily find the fetch method here. This operation called casting, yeah, because we are asking Java to transform the definition of this object from the class animal to the class dog. And in that way, compiler sees that dog extends the animal. A actually is possible to be fetched to the dog and reassign it to the class of, to the child class of this whole structure. So in this case, we can call this fetch method. Yeah, here it's not possible because it's not defined in the animal level. Yeah, it's in red. But in case when we are fetching it to dog, we can call dFetch, and this method will be executed. Any questions here? Students offline, is it clear for you?
Yes.
Perfect. Let's go back to the presentation then. Yeah, so here in the example, more it's implemented in a more secure way. Let's go back to the presentation mode, because we are checking if my animal is an instance of the dog. So it's possible that animal is a cat, and when we are trying to fetch it to the dog, we'll obtain the issue and we'll obtain an exception, like casting exception problem. So this example is more advanced and more secure, and we are checking if it's possible to cast my animal to the dog. If yes, then we are doing that. As you can see here, if my animal instance of the dog, then apply the casting. And we can call the fetch method. I think it's clear as well. Good. Abstract classes. A lot of you already use these classes in your homework assignments. So please raise your hand and try to explain what is it.
The circle.
The circle and the shape. But actually the question is, what is an abstract class?
It is a class that doesn't have it has some methods that don't have an implementation of the superclass and have to have an implementation in subclasses.
That's right. So thank you. And yeah, here you can see the good example called shape. And it was already mentioned by you that B may have a general shape, and it's pretty clear that we can decolor. But the way how to calculate an area should be different, and it depends on the type of this figure. If it's a circle, we are calculating like P by radius and radius. If it's a square, we are multiplying the A by A, where A is part of this square. So we cannot define on this level the logic how the area should be calculated. So it's an abstract. Abstract classes are the classes where we may have abstract methods. An abstract method is a method definition without the implementation. So we cannot directly instantiate the abstract class. In case you will do that, it will be required to provide the implementation of this method, so called anonymously. Yeah, so what it brings to us, we can define a general logic in an abstract class, which is already known on this level. Getting the colors, getting some additional attributes and other things. But if area or perimeter or other things couldn't be defined on this level, we are calling them abstract and providing the implementation in subclasses, like here in the circle. This example says that we are creating a circle. Circle is defined by radius of or circle extends everything from the shape. And also we need to provide a color and radius. Color being called from the super constructor and defined here. Radius defined directly in the circle class. And we are overriding the area method. Again, let's go to example in IDEA quickly. What I did, I've implemented animal as an abstract. Voice method is an abstract one. So we don't know how to implement the voice of the animal if we do not know precisely what this animal kind of, yeah, so if it's a zebra or if it's a tiger or anyone else. Yeah, so by extending the animal class with the doc implementation, we are defining the voice depending on the class itself. Dog is saying the woof, cat is saying the meow. Typical question is, what will happen in case when we define the animal anonymously as an abstract class? So let's try to play around. Animal AA equals new animal. Yeah, and as you can see, it requires the color, not the color, but probably name. Let's call it Rex, age 5. And Java directly asks to implement anonymously this voice method. So it's not possible to instantiate the object without the definition what should be performed here. You can say system out, print on woof. It's possible way how to directly in your main code define the implementation of voice method, but it's highly recommended to do not use this because the main implementation should happen in the subclasses. I think it's clear as well. If you have any questions, please don't hesitate to raise your hand. Good. Let's move to the next one. Generics. Well, generic types make the code more flexible by allowing it to operate on various data types while providing compile time type safety. You probably already worked with them by using Java effects components or some of collections. And a good example is a list. So in a list, we can collect everything like integers, circles, shapes, animals, whatever we want. And the main logic should be the same: to add to the list, remove from the list. And yeah, we can operate by anything. Yeah, we can put and add students, we can add animals, and that's how generics helps us. Generic box, it's actually an abstract, you can imagine a typical box where you are putting in anything inside of it. So you can put the cat, you can remove the cat, get it from the box, you can put a clock and get back the clock. So we can use box in different ways and put everything we want. But for the Java and for other programming languages, it's important to understand exactly what you are putting there, but the main logic would be generalized. So for box, it doesn't matter what you are putting inside of it. But on the outside world, yeah, you should define. Here you can see the example. Generic box on the left side has a private field like a T, so it could be anything, and we can set and get this value inside and outside of the box. In a real main application, in a precise usage of this functionality, you are saying generic box has an integer. So we are saying explicitly here that we are putting in this box integers and defining them. Or we can put strings. String box equals generic box. So we have two boxes, and we are saying in one we are putting strings, in other we are putting integers. The same thing works perfectly with the collections. Let's quickly try to play around with it. We may have list of animal. Yeah, I need to import this. A equals new animal, new array list. And what it shouldn't be animal, a list, let's call it in this way. And also we can define the list of integers. I list, new array list. Both of these objects have the possibility to add, like in the I list, should be as here. In the I list, we are adding numbers. In the A list, we can add new dog. So this is an additional way how we are making our code more elegant when we are using more general abstractions by working with different type of objects. So here we have animals, here we have integers, operations like add or remove, technically the same. So we are removing somewhere from array inside of the implementation of array list, but the kind of objects are different. And we are saying which kind of objects in the definition of the class here. Any questions here? If no, yeah, so let's go to the next quite important topic called wrappers and autoboxing. Also, I remember, based on the sum of homeworks presented to me, that you were already using them. So any suggestions? Does anyone know what is that and can explain? Okay, so let me try to explain it in detail. As you can see here, and in the example I've provided in the idea, we are using integer like a generic here. It's an object. But also we have a primitive type. Primitive type is an int. Right? So let's try to play again. We have this array list. I defined it as a list of integers as an object. But what about int? We cannot assign it. So in Java, there are two kind of objects we are, two kind of data types we are operating with. Primitive types, and also we have an objects based on this primitive type. So for int, it could be integer. For double, it could be double. Okay, I'll put it here. And so on and so forth. Why do we need it? Actually, everything in Java is an object. But in case when we are defining the generics, like list here, it should be operated only with the object. As you can see here, it says E, and E somewhere in the details of the implementation extend the object class. And yeah, but what to do? Because how should we define numbers and all of these primitive types in our system? So for example, we may have int a, int z, for example, equals to 5. Can we directly add it to the I list, which is a list of integers here? That's the question to you.
No.
Why?
Because it takes a generic type integer, not just an int.
Let's try. Not remove. Let's add z. And you know it's working. Yeah, and if you'll compile, it will work as well. Why it's working? Well, because it's completely understandable that the nature of this primitive type and object integer is the same. And Java understands that for the primitive type int, we have a respective object integer, and we can autobox. So it automatically converts the z equals to 5 to the integer objects and adding it to the list, which simplifies the work of the engineer. So we can also try to play around with it and just say integer z equals z. Perfect. It works. And that's a good example of autoboxing. So as you can see here, you can find more advanced examples. Yeah, we have integer, like int wrapper equals to 5, double wrapper equals to 5.5. We are also redefined int wrapper manual and defined it as an object as well. Here is a primitive type. Here it's actually an object. And we can easily convert it back and forth from the primitive to object, vice versa, if needed. And in case if you are working with array list, for example, and put in the number as a primitive, it will be working. So it auto boxes from int as a primitive type to the integer. And unboxing. So here we are just getting the first element of the array. It's completely understandable for Java that it could be assigned and unboxed to the primitive type. Yeah, and that's a good functionality. So you're not providing the overhead code and not casting from primitive to the object and vice versa. Is it clear for you? Any questions?